how it's the brightness is increasing too fast, and then it goes to 0 and it go to the 100% brightness. So here you go. So you see, if I make it only 10 Hz, that is too low frequency, then we see some flickering effect. Although, alright. So in this video, we will explore the pulse width modulation on Raspberry Pi Pico. We will learn how to use the PWM to control the brightness of an LED and many more. In my previous video, I showed you how to use digital input and output, and the link is given in the description. So let's first try to see what does the PWM means. So when we use the digital output of this Pico board, we can have two options. We can turn on the digital output pin that will give us 3.3 volt, or we can turn it off, which will give us 0 volt. So we only have two options, either 3.3 volt or 0 volt. But how about if we need something else? If we need something in between, for example 2 volt. So for this kind of situation where we need the voltage in between 0 to 3.3 volt, we will use the technique of this PWM. PWM is a technique to simulate analog output using digital signal. It works by rapidly turning on and off the digital output pin, and the average of this on and off will be the actual analog output voltage of that specific digital output pin. Let's dig into more deeper. For example, if we say for any specific amount of time, like if we, for example, if you take this is the time period, for that specific time, we may turn this digital output pin on for half of this time, and we may turn it off for another half of this time. So if we do this, then the output will be like this, because we turn it off for 50% of time. Then this, let's say this is the 3.3 volts, so it is turned off for 50% of time and turn off for another 50% of time. So because this is turned off, we write it 0 volt and 3.3 volt, and this will be 0.5. so the voltage will be 1.65 volt in this case. And let's say we turn this, the period will be same, so we turn this on for 75% of time and turn it off for 25% of time. In that case, the voltage will be 0.75 with 3.3 volt plus is turned off for 25% of time. So this will be, let me calculate this one, 0.75 into 3.3. so this is 2.475 volt. And if we turn it on, for example, that is 100% of time, then this is so it is 1 into 3.3 plus 0 into 0, because the 0% time it will be turned off 0 volts, so it will be 3.3 volt. So by doing by changing the width of this pulse, we can find different analog voltage. So this is the basic idea behind the pulse width modulation, and like this will just goes on. So in the next period, it will be look like this, and it will goes on. So it will look like this in the next period, like this, and it will goes on. So it's the, for this case it will be always 100%, so it will look like this. So this is the basic idea, and for other microcontroller, this maybe this 3.3 maybe 5 volt, so that doesn't matter. So every time we control the width of this pulse, we will have different voltage level. So now let me tell you how we can implement this in the Pico board using the MicroPython. The MicroPython has 16-bit PWM, so the total number of level will be this 65536. That means when we want to like turn on an LED to the full brightness, if we want the 100% of the pulse width, that corresponds to this number 65536. And if you want 50% of the pulse width, this will be like 65536 by 2, because this is the 50%. And if you need 25% of this one, then it will be 65536 over 4. So this is the very basic idea. And if you want just 0%, then it will be 0. So few things you need to be careful when you are going to implement PWM with any kind of microcontroller or the Raspberry Pi Pico board. You need to be careful about this bit. For example, if your microcontroller is 8-bit, then the maximum you can go is 255. So this number will be 255 in that case. And for that case, if you want to have some like 50% pulse width for any 8-bit microcontroller, then the value will be 127. But because in our case this is 16-bit microcontroller, we are going to use the value for 50%, 65536 over 2. So we can just find this value for this one, and for some other microcontroller we can just use this technique. We need to be careful about the number of bit for that specific microcontroller. We also need to be careful another things for the microcontroller or the PWM, that is the time period. As we have already seen, this is the time period of this one, and based on this time period it might have some effect. For example, if you are going to switch some like transistor or MOSFET, you need to know what maximum frequency you can use for that specific transistor or MOSFET. Also, in case of LED brightness controlling, you need to know like the frequency, the max frequency you can go with this. If you go with too low frequency, you will see flickering, or you will you might have some problem if you cannot handle this frequency correctly. I will show you this effect of frequency in a minute. If you love this video, please give me a thumbs up. That will inspire me to make new videos, and don't forget to subscribe my channel. So I connected an LED to GPIO pin number 1 for this Pico board, and let's now do the coding for controlling the brightness of this. So as we know, the LED pin will be used as an output. So as like the digital output, we need to import the pin from this machine library. So from machine we can import the pin, and we can declare this LED pin as an output. So it will be 1, and this will be pin dot out. So I attached the LED to pin number 1 and declared it as an output by using this line. So if we just confirm everything is working correctly, we can make this while loop, and we can try to see this. So for turning on the LED using digital output, we use the LED.value and we pass the value of 1. So this 1 means the digital output pin will be 3.3 volt that will turn on the LED. Let's just run it. So you see, if I run this one, the LED is now turned on. So the output voltage of this GPIO pin 1 is 3.3 volt, and LED is turning on with this full brightness. So if we wish to control this brightness, we need to use the PWM. So for using the PWM, we need to import this PWM, and we can attach this PWM to this LED. So it is just pretty simple, just we can write this, but we need to be careful about the frequency. We need to add LED.frequency in this case, and I am using it as 1000. That means 1 kilohertz for this case. And for the digital output, we use LED.value, and we pass this value either 1 or 0. But for the analog output or the PWM, we just use duty to 16, and we pass the value 65535 for the 100%. So for the 100% of brightness, this is for this value will be 65535. But we can convert this value for any kind of brightness. Let's just try to see whether it's working or not. So it seems like it working and the LED brightness is full, because with this number 65535 the output voltage is 3.3 volt, because this is the 100% brightness. So, and if you want to see it dim, for example, if you set for 50% of the brightness, then this will be around 3 to, I guess this is around 3 to 768, 3 to 768. So this is for 50% brightness. So if we run this code, the LED will be dimmer. So LED dimmed to is 50%. It might be difficult to see here. Let's just try to make it more dimmer. So for example, I randomly chose this 3000. So I'm not sure what is the percent brightness for this one. Let's just try to see about this. So if I make it more dimmer, you see it's not blinking on 100% or 50% brightness. It is more dimmer because the value is 3000. So this value could be anything from 0 to 65535, that corresponding to 0% brightness to 100% brightness. So if you want to see a fading effect to this LED, we can use a for loop for I range. We can say 0 to 65535, so that is the range, and we can increase it with 1000. So if we do this, and then we can set this LED dot duty U16, and we can pass the I here. So if you pass this I, and let's try to make a pause. So for making the pause, I will use utime dot sleep and pass 1 for pausing about 1 millisecond, and I need to import the utime library here. If I now run this code, you will see the LED brightness is changing, and it's changing every 1 second. So it will start from duty cycle 0%, and it will gradually increase to the duty cycle of 100%. Let's just wait for sometimes. It will go to its full brightness, and after this full brightness it will dim again. It will start from the 0. Okay, I guess the wait time is too long. Let's just change this wait time to see how faster it can work. So I can make this wait time just this 0.1, and let's run it. So you see now is the brightness is increasing too fast, and then it goes to 0, and it go to the 100% brightness again. So now it's in the full brightness, then it starts from the again, because every time when the loop is done, it starts from the 0. So this is how we can control the brightness of the LED. We can also do the same thing for controlling the speed of any DC motor, or in any other case where we need the analog output voltage, we can use this technique. Before finishing this tutorial, let's just try to see what's the effect of this frequency. For example, if I change this frequency to 100 Hertz, let's see what's happening. So let's run this one. If I run it with 100 Hertz, I think because my LED is just blinking from 0% to 100% brightness, it might be difficult to see this. Let's reduce it more. Okay, so here we go. So you see, if I make it only 10 Hertz, that is too low frequency, then we see some flickering effect. Although it's changing the brightness from 0% to 100%, but we see something flickering because it's switching with a slow speed. But if we make the frequency very higher, it will switch in between on and off with a very high, so that we will not see this flickering effect. I now set this frequency to 10 kilohertz. That means it will switch on and off too frequently, and that will not be seen in our eyes. You see, so this is too smooth and we will not see the effect of flickering here. We just see the changing of the brightness. So just be careful with this frequency, because it might create some effect of flickering, or if you try to drive some relay or some other electric component like the MOSFET, they might have some inherent limitation to use the frequency. But this is all for this tutorial, and see you in the coming videos.